Hello, this is question 12 on your AS level June 2022 paper from Edexcel. You have one of those modeling questions with differentiation that are quite similar to each other. So you have a company that makes drinks containers out of metal. The containers are modeled as closed cylinders with base radius r. So I already draw the cylinder. So the base is radius r and the height is 8 centimeters. And the capacity of the container, so the volume, is going to be 355 centimeters cubed. The metal used for the circular base and the curved side costs 0.04 pence centimeter squared, and for the circular top 0.09. So the side and the bottom has a price. Side and bottom is 0.09 pence centimeter squared. The top is a different price, 0.04 pence centimeter squared. Then they say, show that the total cost C in pence is this formula here. So if we try to work out the cost in general, so the cost is going to be the area of side and bottom times this value, and the plus the area of the top times this value. So we will have something like 0.09 times the area of the bottom is pi r squared. The area of the side is 2 pi r8, so the rectangle, and the top is going to be 0.04 pi r squared. So you can see that the cost depends on two variables, r and h. That's why they give us always a line to eliminate one of the variables. So this is the line. This is the line. The volume is 355, which means that the volume of the cylinder, so the volume, which is 355, is going to be pi r squared times h. And from here, I can eliminate the variable that I don't want. In this case, the cost is given in terms of r only, so in my formula I'm going to eliminate h, and I'm going to get h in terms of r from this line here. So h, and it's going to be the case in all this type of questions, so 355 divided by pi r squared, and this is what I'm going to substitute in my cost function. Yeah, so this bit here, this is going to be 0.09 pi r squared plus 2 pi r, 355 divided by pi r squared plus 0.04 pi r squared. I can cancel this with this and this pi, and when you organize and when you multiply your values, you are going to have the expression that you need. So you have 0.09 pi r squared plus 0.04 pi r squared is 0.13 pi r squared, and this 0.09 times 2 times 355 divided by r is my 28.4 divided by r. That's the cost, and that's what I have to find. Yeah, so this is the first part. And this is going to be the case in all these questions. So you are going to have an expression that depends on two variables, and you are going to be able to eliminate one of them with something that they tell you. And the purpose is that you are now able to differentiate in terms of that variable, and that's the whole thing. Then use calculus to find the value of r for which c is a minimum, giving your answer to three significant figures. Now what we are going to do is to differentiate this expression and make it equal to 0. So if I differentiate that expression, so for b, I'm going to differentiate the costs in terms of with respect to r, and it's going to be 0.13. So you see the 0.13 times 2, which is 0.26 pi r, 0.26 pi r. And then the second part is having r minus 1, so it's going to be minus 1 times this value here times r minus 2, 1 less. Yeah, so this is like having 28.4 times r minus 1. When I derivate, I have minus 1 28.4 r minus 2. So minus 28.4 r minus 2. So I can write the r minus 2 here in the denominator. And this is going to be equal to 0, which means 0.26 pi r cubed minus is going to be 28.4. And from here you can find r just very easily, and you have 3.2638 something else, and they say round to 3 significant figures, so this is going to be 3.26 centimeters to 3 significant figures. Remember to give units when you are given units. Yeah, so if you have a modeling question, when you give a number, give your answer with units. Using the second derivative, prove that the cost is a minimum, right? So we are going to do second derivative. So we are going to derivate again with respect to r, this expression now. So this is going to be 0.26 pi. And then this is like having minus 28.4 r squared. So when I derivate that, I have minus 2, sorry. I have minus 2 times this becomes positive, and double, which is what, 56.8 r minus 3. And this is going to be positive for any value of r. And if you want, you can find the when r is 3.26, so when r is that value, when r is 3.26, this is going to be 2.45, which is positive, therefore is a minimum. But it's going to be positive for any value, because I have a positive value and a positive value. The r is going to be always positive, because it's a distance, yeah, a length. The last part says, hence, find the minimum value of c, giving your answer to the nearest integer. So we found the value of r for the cost being minimum, but we haven't found the cost. So what we are going to do is just substitute in the cost function, that is this this expression here, this one, 28.4. The value of r that we just found. So the value of r is this one here. So when r is 3.26, we have 13.052, and they say to the nearest integer, so the cost is going to be 13 pence to the nearest integer. Yeah, and that's my answer. And that's all.